Hey y'all, welcome back to Alakazam Math Made Easy. In this video, we're going to go over the last topic before the review. So the next video will actually be the limit content review if you wanted to check that out. That'll be a super surface level review of everything we've gone over. And if there's any topics that still confuse you, look back into the videos. But for now, what we're going to look at is the formal definition of a limit. And what I did is I wrote here in orange the actual language of it. But I kind of don't really want to pay too much attention to the actual language because I kind of want to explain it a little bit differently, right? So all you have to know is this is the format of a limit that we're using. So the actual number we're approaching is a, the function that we're looking at is f of x, and the limit that we actually get, the final number that we calculate, we're calling L, right? What we do need to know are these equations down here, right? So this and this. And what we're going to end up doing is we're going to be kind of playing with these equations to try to relate epsilon and delta here. So that's kind of what we're going to do. In principle, what the formal definition of a limit is it says that if I'm playing around with my x value between a range of plus or minus delta, what I'll end up doing is my limit will be somewhere between plus or minus epsilon, L plus or minus epsilon. So basically all it's saying is that as I move around in this box, it'll end up moving on both axes. So that's all it's saying. Well, let's actually get into like the math behind it, because this is kind of what the problem will look like. It'll give you a function and it'll give you a limit of that function, and it'll tell you what the answer is, and it'll say prove that this is true using the definition of a limit, right? So first what we do is we have to like establish our values, right? So we're given that L is 0. Remember, L is what the limit is equal to. We're given that a is 0. Remember, a is the number that we're approaching. And we're also given that f of x is x squared. So that's what we're given. Remember, the premise here is we're playing around with the relationship between epsilon and delta, right? So what we're going to end up doing is relating the number of the variance in the y direction to the variance in the x direction, or like not the variance like in a statistical method, but like we're moving around from the actual value. So we pick one of them to be a random number. Epsilon is traditionally easier to pick to start with, and you'll see why in a second. But for now, we'll call epsilon equals 0 a random number, and we're going to try to find some delta equals greater than 0 that makes that true, right? So first of all, we have to plug in our values that we just found into our equation. The values were given into our equation. So that's what I did here. So we plugged in f of x becomes x squared. We're given L is 0. Epsilon and delta will stay the same. X is still x, that's the variable we're working with, and we're given a is 0. So now everything is plugged in, and we're going to simplify it to get rid of all of the zeros, basically. The 1 0 we can't get rid of is this one, because that's built into the actual function. Anything plus or minus 0, we can get rid of. So now we've got it simplified. So we're going to start with, and this is why it's easier to choose epsilon to be your random number, we're going to start with this function. Because even though this one looks more complicated, epsilon will allow us to, so basically what we're going to end up getting at is the fact that this absolute value of x is trapped between two of these. So it's really, really hard to play with, right? Whereas this x absolute value of some combination of x is not trapped between two, it's only on one. So we're going to solve this section here for the absolute value of x so we can get some version of epsilon and substitute that in for delta. So we're going to start with the left-hand side, and we're going to solve this so it's x squared, right, inside of it. So what we do is we take the square root of both sides, which gives us the square root of the absolute value of x squared is less than the square root of epsilon. So then the squared and the square root will cancel. So then we're left with the absolute value of x is less than epsilon, which, if you notice, is written exactly like this left-hand side over here, or this right-hand side, sorry. And basically what that allows us to do is, because those formats look exactly the same, we can call delta equals square root of epsilon, right? So you might be thinking, all right, what happens with this piece that we haven't talked about yet? All that tells us is we can't test this by plugging in 0, which is fine because we just won't do that. So we can kind of ignore that for now. So now we have to actually verify that this works, right? So what do? We plug in the square root of epsilon for delta, where that was in the original equation. And then we try to get everything back to where it was, right? We try to get all of this back to these equations. I guess technically these equations, because we've simplified. So now that we've plugged everything in, we can also pull out this squared, so it's outside of these absolute value bars. So that's what we'll do. We'll combine both of those principles. So that's what I did. I pulled the squared out here, and then I said it's less than epsilon because that's what the equation says. And then this other inequality says the absolute value of x is less than what we called delta up here in this step. So now we have those two. And what I need to do is I need to figure out, okay, are these two saying the same thing? And you'll notice that to get from this x to this x, I have to square it, right? So I'm going to square both sides of this one, which is what happened here. So I have these squared, but also the square root of epsilon squared, which gets me back to something very, so it gets me back to exactly this form here. And then when I pull that squared back into those error bars, it ends up with exactly what I ended up with when I simplified my equation. So basically this whole game is use the left-hand side. So get your equations, right? So we'll get our simplified equations. And then I need to use my left-hand side to get back to a value of delta that I can use. And then I use that right-hand inequality with my new delta to try to get back to the left-hand inequality. So the logic is kind of goofy and a little bit circular sometimes, but basically that's how you need to go about proving that a limit is true using the formal definition of a limit. So if you've learned something from this video, please like it. If you want to keep up to date with the videos that I'm posting, subscribe to my channel and turn on the notifications so that you'll get a notification to your device whenever I upload a new video. If you have questions, feel free to leave them in the comments. I'll address them as soon as I can. And as usual, otherwise, best of luck.